All right, so today we're going to go over an actual free response problem for it's the six free response problem that is Taylor series. And I'm not sure why it's doing that. Go away. Hang on a second. And get rid of this. There we go. All right. All right, so let's read the problem first. This is 2016's free response that was released. And it says that we have a function f that is a Taylor series about x equal 1. When it says about x equal 1, that means that's the center. It's centered there. And that it converges to f of x for all x in the interval of convergence. It is known that f of 1 equals 1, f prime of 1 equals negative 1/2, and the nth derivative of f at x equal 1 is given by the nth, f the nth at 1 is negative 1 to the n minus 1 factorial over 2n for n greater than 2. And they want you to write the first four non-zero terms and the general term for the Taylor series about x equal 1. So we're going to do part A now. So for part A, hang on a second. Here we go. Oh, lost it. Okay, just had to get rearranged. All right, so we know what our first term is. They've given us our first term. So there's the first term. There's the second term. And then all subsequent terms are using that formula. So it's pretty basic. Well, I mean, in that is the first term, but this is the coefficient. Well, part of, we use that to find the coefficient. Remember for Taylor series? So let me just write it. It's easier to show you than explain it. I'm having trouble with my words. So the Taylor polynomial. This is we want the Taylor series for it, right? And it is going to be the first term is the 1, which is f of 1. And then it's going to be minus the 1/2, which is the derivative evaluated at 1, which is the center, times x minus 1 all over 1. That's the n equal 1 term. And then my next term is going to be, so I'm going to do plus, and it's going to be negative 1. So this is squared. So this is, if we're looking at our n's, this is 0, this is 1, this is 2. So this is going to be x, it says that the coefficient, the derivative, I got negative 1 squared times 2 minus 1 factorial over 2 squared. And that's all going to be times x minus 1 squared, right, when we plug it all in. And then our next term, our third term, is negative 1 cubed, and then it's going to be 3 minus 1 factorial over 2 cubed times x minus 1 cubed. Right? So notice we have 4 non-zero terms. 1, 2, 3. See, 1, I'll highlight them so y'all can see what I'm talking about. There's 1, 2, 3, 4 terms, right? And then we have to add the general term. Now they want us just to write the general term, and then it's going to be plus, so plus, dot, 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 plus, and our general term is going to be the negative 1 to the n power of, n minus 1 factorial over 2 to the n times x minus 1 to the n power. And that's our Taylor polynomial. So that's part A. And okay, the reason I paused, I had to go get the scoring guide because I couldn't remember the scoring. I remembered that just being able to do this was a lot of points, a ridiculous number of points. Remember how I told you like 5 or 6 points is easy? Well, that part A is worth 4 points. They gave you 1 point for the first 2 terms. They gave you another point for the third term, another point for the fourth term, and a point for the general term. So basically you got a point for the first 2 that they gave you, essentially. You got a point for each of the 3 that you had to make yourself. So that was worth 4 points right there, which is really easy peasy lemon squeezy basic Taylor polynomial or Taylor series. Then there's part B. And in part B, they want the Taylor series for f about x equal 1 has a radius of convergence of 2. They tell you that the radius of convergence is 2 because they haven't given you the actual function. They want you to find the interval of convergence. So what you're going to have to do is plug it in, right? You're gonna have to plug in the x values and see if it converges. The series converges at those points. So it's basically you're turning it to the general. So for some reason, there we go. Now it's starting to move. Okay, so for part B, what we do is, okay, for part B, we have that r is equal to 2. That means my radius convergence is going to be -2 to 2. And the only question mark is, does it converge at the two intervals? Oh, wait. That was really silly of me. This is as I was doing for Maclaurin. This is at x equal x minus 1 is between 2 and -2. Which means if I add 1 to all three parts, then I'm going to get -1 to 3. And the only question mark is at -1 and -3 whether or not it's going to converge. So I have to check. So we're going to do at x equal to -1, and we just plug in, and we've got, all right, so we're going to have, when we check at the, so f of x is equal to the first term, right, minus 1/2, and we know what x is, it's -1, so -1 minus 1, right, and then it's going to be plus, and then we put in 1 over, because it's squared, so it's 1, and then it's 1 factorial over 4, right, times, nope, it's 4, and then we have -1 minus 1 squared, right, so that's just 1/4, and then we're going to just jump ahead to the nth term, so now we have -1 to the n power times, and it's going to be -1 minus 1, and this will be to the n power also, and then we're going to have over 2 to the n power times wait, I already did that one. Oh, I've got to do the, oh, that's what I messed up. I forgot. I wrote the wrong thing. I got my eyes skipped. It's n minus 1 factorial times -1 minus 1 to the n power, right? And we can simplify this hang on. I left off something. Oh, that's what I did. All the way back here. And y'all aren't here to help me, because I started writing, and I did the first one, that's fine, but in the second one I was supposed to times 2 factorial. And this was supposed to be times 3 factorial. I left that off. And this is n factorial. I knew I was forgetting something. In any case, that's much better. All right. Because I was sitting here going like, I'm forgetting something. Well, okay, so this should have been divided by 2 because it's 2 factorial. And then this is going to be, oops, I lost it. I'm back. And this is times, in the nth term, this is going to be n factorial. And so what we have to do is we have to compare this to this and see what's going to go away. And we got to see what happens with all of this. right? What's going on here? Because we need to simplify. So we're going to rewrite it. So we're really looking at the nth term. We want to know, is this going to converge on this nth term? So we got to look at the nth term and rewrite this whole thing, right? So what we're going to do is we're going to just rewrite it as, so we're going to make it, and we're going to simplify it, but we're going to say it's the summation of n equals 1 to infinity, and then we're going to have, so we have a negative 1 to the n power, and then we have n minus 1 factorial, and then we're going to divide this by n times n minus 1 factorial. And then here we're going to have, this is really negative 2, so we're going to have a negative 1 to the n power times 2 to the n power. I'm just going to write 2 to the n power over 2 to the n power. All I did was I'm comparing this to this, and then I've got the negatives. So what happens is that goes to 1, that goes to 1, and this simplifies to the summation of n equals 1 to infinity of negative 1 to the n, so that's negative 1 to the 2n power, which is even, which means it's going to be positive 1. So it's just positive 1. And the only thing left over here is times 1 over n, which means this is harmonic. So therefore, it's not going to converge here. Therefore, the series diverges at x equals to negative 1 because the series, or because it is the harmonic series. Okay, so we've taken care of one of them. Now we got to do the next one. Now we got to go x equals to 3. That's where our next one was, right? So we already know from this that it's not at negative 1. So now we have to check at 3. So we're going to write that same summation that we did right up there. Eventually, after we wrote out enough terms, we went, oh, I just need the nth term. We'd have to go ahead and figure that out. So for this one, now we have f of x equals the summation of n equals 1 to infinity of negative 1 to the n times n minus 1 factorial times 3 minus 1 factorial. Oops, no, that's to the n. To the n over, and then I'm going to put the 2 to the n here for obvious reasons. I'm going to put the n factorial here. It's going to simplify the same way. This is just 2, so that goes to 1. This is going to be written as n times n minus 1 factorial, which means those cancel out. And then we end up with the summation of n equals 1 to infinity of negative 1 to the n. And then it's going to be times 1 over n, which is the alternating harmonic series. So we know that it converges there. So therefore, the series converges at x equals 3 because it is the alternating harmonic series. And we now know, so therefore, the interval of convergence is negative 1 less than x less than or equal to 3. And we're done. Yay. And let me go look at the scoring guide for you. So that was 2 points. You got 1 point for identifying both endpoints, and you got 1 point for doing the correct analysis and getting the correct interval of convergence. So basically, if you didn't do both ends correctly, you didn't get a point. You didn't get that last point. But as I said, remember how 5 or 6 points? These are basic things. Y'all are supposed to know at this point harmonic and alternating harmonic. You should be able to set up a Taylor series. So that was an easy 6 points. Really basic, nothing tricky, exactly what you're supposed to know how to do. So that's what I was talking about, where these problems actually are not that bad. If you'll just be able to do the basics, you can get 5 or 6 points. And now we have to go to do the last part. The last part for part C. Now we got to do actually 2 parts, C and D. So C, because I promised I would do error with you today. Part O. Wait, something's not right.